This is the video for the negative exponent exploration. Our objective today is to be able to rewrite expressions using properties of exponents. In previous lessons, we've talked about the zero exponent property. Now we're going to talk about what happens with negative exponents. Our focus question for today is, does a negative exponent make the base negative? And what effect does an negative exponent have? The most important thing to notice about an exponential expression is what part is the exponent applied to? The whole thing, the numerator, the denominator, only part of it? You got to pay attention to that. And then what effect does a negative exponent have on an expression? Let's find out. I'm going to simplify these expressions, and hopefully you'll notice a pattern. 2/5 to the negative 1 power is 5/2. 3 to the negative 1 power is 1/3. 7/3 to the negative 1 power is 3/7. And 4/9 to the negative 1 power is 9/4. Now you might notice that the negative 1 makes this do the reciprocal. The numerator and the denominator switch place. So then where does the 1 come from in 1/3? All of these have a numerator and a denominator. This one doesn't seem like it does, but we know that it does. We know that this is actually 3/1 to the negative 1. So the same thing is happening. The negative 1 is causing the numerator and the denominator to switch places. Now what I want you to do is I want you to predict what you think the value will be. Pause the video at this point and write down your prediction. You can write it just below each expression. Let's see if you were right. This is 2. This is 2. This is 3. And this is x/3. What just happened? Well, the 2 and the 1, because of the negative exponent, switched places. That's what this is. But this is the most simplified answer. The 4 and the 2 switched places. But 4 divided by 2 is 2. This is the most simplified answer. The 6 and the 2, because of the negative exponent, change, but 6 divided by 2 is 3. And here, we don't know what x is, so we just leave it alone as x/3. We don't have to simplify it any further. We can't. So what is the rule to generalize this pattern? A/b to the negative 1 is b/a. And if you want to write it out in words that the numerator and denominator switch places, you can certainly do that. What would happen if there is a negative exponent that isn't just 1? Let's find out. I'm going to flip the numerator and the denominator, and I'm going to raise it to the 3rd power. So really what's going on here is this is 5/2 times 5/2 times 5/2. The 5 and the 2 switch places, but then I have to multiply this times itself 3 times because of the exponent. So once I simplify everything, it's 125/2. I would not take a calculator and simplify this any further. By writing my answer as 125/2, I'm demonstrating that I know how the power of a negative exponent works. This would be 1/27. I know that the negative exponent will make what's actually 3/1 switch places, and then I'm going to multiply that times itself 3 times. This will be 9/49. 3 squared is 9, 7 squared is 49. This will be 81/x squared. 9 times 9 is 81. X times x is x squared. So now you pause the video here and practice these. How'd you do? This should be 8. This should be 16 over 25. This should be 64. And this should be 100 over 4. But if you wanted to simplify that to 25, it would be okay. There's no decimals involved here. I left this one the way it was because I don't really need to simplify it to a decimal. Now look at all these expressions in this lesson so far. Do negative exponents ever make a number negative? Look at all the things that I have written in green. Did a negative exponent ever make a number negative? The answer is no. Does a negative exponent make the base negative? Never. What would happen if part of the expression has a negative exponent, but not the whole thing? This is what we're talking about when you have to pay attention to which part of the expression does the negative exponent actually apply to? In this case, the negative exponent is here on the 4, which means that this 4 is going to move from the denominator to the numerator. The 3 doesn't have an exponent showing. It's not going anywhere. So the 3 stays in the numerator. The 4 moves from the denominator to the numerator, and it gets multiplied by the 3. There's actually, we understand, a 1 in front of here. We don't have to write it, but you can if you want to. And so that would be 12. In this case, again, there's an understood 1 in front of there. The 4 doesn't have an exponent showing. It stays there. The 3 with its negative exponent moves into the denominator with the 4. And so this simplified would be 1 over 12. In this case, both the numerator and the denominator have negative exponents, so they're both moving. The numerator moves to the denominator. The denominator moves to the numerator. I don't write the 1 as an exponent here. If you do, it's okay, but we understand that it's there. In this last example, it would be 3 divided by 16. What just happened? Right now, there's not a denominator showing, so we understand that each one of these is over 1. The 3 isn't moving anywhere. It stays right there. The 4, however, moves to the denominator. 4 squared is 16. That's why that's in the denominator. And if you multiply that all together and simplify it, it's 3 over 16. So pause the video right now and do your best to guess how these next 4 expressions would be simplified. Let's see how you did. Did you write 1 over x to the 6th? Did you write x to the 3rd? How about 2 over x to the 4th? The 2 doesn't have an exponent being applied to it. The x does. This would be 3x to the 5th. If you want to, you can say that this is over 1, but we understand that to be true. Of course, there's a 1 right here. When this moves up to the numerator with the 3, the 1 is still there, but we don't have to write it because we know that it's there. Again, pause the video and practice. The 1 has nothing happening to it. The 5 has nothing happening to it. But the x has a negative exponent. This is going to move this variable into the denominator. 1 times anything is itself, so that's x to the 10th. The 5 stays there. Both of these move with their exponents. This is one that we haven't had so far. This is different than the one above it. In this case, the negative 4 only applied to the x. But here, the negative 3 is applying to everything in the parentheses. So this will go into the bottom. the x will be cubed, and 2 cubed is 8. 1 over 8x to the third. You might say, where does the 1 come from? We understand that there is a coefficient of 1 here, even though we don't write it. And finally, this negative 2 is applying to everything in the parentheses, the entire fraction. Here the negative exponent only applied to the x, but here it's both. This would be x squared over 9. Your job now is to try the next 14 exercises as your check for understanding. Good luck.